Welcome back to week 6, and in video 4 we are going to talk in a little bit of detail about glaciers and climate change and what that relationship is. So throughout geologic history we've seen evidence of glaciers being much larger than they are today. So here's a picture of a map of glaciers today in white, and then this map down here shows you glacier size about 20,000 years ago. So you can see much larger volume of ice. So throughout geologic history, glaciers grow and shrink over time. And some of these are due to natural cycles in the Earth, orbital cycles, maybe some sunspots, atmospheric cycles. But what we're seeing more recently with what's going on today in the atmosphere is we're seeing a rapid decrease in the size of glaciers and a rapid increase in the amount of CO2 in the atmosphere. So much so that the increase in volume of CO2 in the atmosphere is increasing at such a rate that we've never seen it in the geologic record before. We have no evidence of this happening. It's such a fast time frame. And so these glaciers, so you can see Sperry Glacier and Glacier National Park here in 1913, the approximate size, and then in 2008, and this was 4 years ago, so you can imagine what it might look like now, almost gone. And then here we can see the South Cascade Glacier kind of close to where we live in 1928. You can see that glacier kind of extends down and around the corner here, and then we have our till building up. In 1979, here's the terminus of that glacier would have been right about here. You see a lake has formed, and it's backing up the valley even further. This peak right here is kind of cut off, is the same peak as what's right here. You can see here 2000, there's that lake. Our terminus has moved up valley even more. You can see in 1979 it was right next to the lake. Here it is much further back. Here's that same peak. You can see here, same peak, and then here's that peak again, and you can see it's retreated much further in 2003. So we see this decrease in size, decrease in volume all over the globe. And what happens, one of the main things that happens when we have this change in ice volume is we see a major change in sea level. So when our ice sheets were much larger 20,000 years ago, our sea level was lower. And we know that for many reasons. We see sea caves, we see in that continental shelf that we see the exposed area in yellow, we can see evidence of river valleys in that continental shelf because we have great technology to be able to image the seafloor surface. We can see right where the Columbia flows out, we see a huge canyon, a submarine canyon that was once above sea level, which is pretty amazing. So now that all this ice is melted, sea level has risen to where it is today, and now we have the Greenland ice sheet, and we have all these smaller glaciers in our neck of the woods and up in Alaska that are rapidly decreasing in volume, and all that water is emptying into the oceans. Pretty scary stuff. And so what does that mean? What is all this stuff telling us? Well, we know our carbon dioxide concentration, you can see this graph, is increasing. So this is going from 1880 to roughly 2000. You can see the CO2 levels are increasing dramatically. We also see, if we look at our global temperature records that we've got, we see our global temperature was pretty low around the 1900s, and then it came up again, and then it decreased, kind of wiggled back and forth from about the 1940s to 1980s, and then all of a sudden it just kind of went on a runaway advance and increase in global temperature. So this data is from the IPCC, or this is from NOAA. You can visit the websites that I posted online if you want more information about global temperature, carbon dioxide, and sea level change. So because we have that increased increased carbon dioxide, increased temperature, we melt our glaciers, our sea level increases. And here you can see roughly what it was, same time frame, 1880, 1940, overall increase because our temperature is increasing. So what we see here is a lot of different things on here. The dots on this are showing you what the value is. The red bars on here are showing you the error. And as you see, the error bars are getting smaller and smaller as you get more recent in time. And that's because we have more accurate instruments to measure sea level. Back in the 1800s, not as accurate. We have, and not just not as accurate, but less recording stations and locations, whereas now we have lots. Here you can see kind of a blow up of 1984 to 2008 here, and you can just see how rapidly that increase is happening. So there's some places, there's some communities like Tuvalu, you can Google that, where there are entire nations that are at risk of being basically submerged under the ocean. So to kind of go along with that, to show you how the snow cover is retreating and then the ice is retreating. Overall in the Northern Hemisphere, so this is 1966 to 2008. Here you can see the general trend is decreasing in snow cover. This is just winter snow cover here on this graph showing you. And then we have spring, you can see a pretty decrease I should say. More of that spring snow cover is gone in 2008 than it was in the 60s and 70s. Fall kind of varies. Summer, you can see it's a rapid decrease. So spring and summer, definite decrease in snow cover. And then overall, an overall decrease. And then our glacier size is even more. So this is glacier volume in the entire world. So glacier volume that we know of, all the glaciers that we've measured from 1960 to 2000, huge decrease. And this is in cubic miles. So the amount of decrease we've had, pretty significant. And so how do we know that CO2 is causing this? Well, we see the increased amounts in our atmosphere. We can measure it. We can put instruments out and know what the atmosphere is like. We have records in the ice. So we take ice cores. So ice cores have bubbles in them. The bubbles basically seal off what the atmosphere was like at that moment in time. And we can get dates from ash layers that are in the ice and count the actual individual ice layers to get what year was that CO2 concentration in the atmosphere. And we know that we've had this significant difference. We can measure it. We can measure the data. And what we have done, or what, not me personally, but climatologists have done, is use different models to compare what we have. So they put in the observed, so we know what we can measure, so we know what's actually happening. And then they create these models using various computer models and computer programs, and they put in all the same information that we are measuring. So they put in values for CO2, we put in like stuff like natural sources of CO2, natural temperature changes, volcanic eruptions, all sorts of stuff. And they split it between using only natural forces in blue, so things like natural CO2 releases, plant growth, things like that. And they only put in, and then they add in the pink bar, both natural and human. So they input our release of CO2. And as you can see, these models, natural forces does not account for what we are starting to see as of 1950. So you can see we've had this rapid increase in temperature, and it correlates nicely with the models for using both natural and human forces. And I've put this website on the course site, so if you would like to look at that in more detail, you can. They have lots of papers published and information regarding this if you would like more. And here, the famous hockey puck graph that I'm sure many of you have seen, going back from today, back 800,000 years from now. You can see this cycle based on the ice records we have, back and forth. We don't see that CO2 increasing at all throughout this history until now. And you can see it just skyrockets, just absolutely skyrockets. Here's today, ish, and maybe a little after, and then they have some ideas of where our emissions would be in 2100 based on emissions standards in scenarios. So the green one's lower. Hopefully we can get there. The yellow one is higher, and that's bad news. Lots of sea level rise and lots of flooding of coastal cities. So hopefully we can get on the lower side and get things to not change as dramatically as things are seen at today. So what might happen in the future? We might see some plants and animals migrating. Alaska glaciers continue to shrink, disappear. The ones in our neck of the woods might even disappear. And that's important because a lot of our water source comes from the glaciers on Mount Hood. So if we don't have that ice, we don't have a water source. We might see droughts in western states because of not only the disappearance of glaciers, but if we have decreased snowmelt and snowfall in the wintertime, we could see major droughts because a lot of the water that those states rely on comes from spring snowmelt. And then if we have Antarctic ice sheets in Greenland increasing to their melt, we can see increased sea level and flooding of major coastal cities. Like you can see New York is basically at sea level, maybe 20 feet, 100 feet above sea level. So there's going to be some significant flooding in some areas. So that's the relationship between glacier change and climate. We're going to come back and talk about arid landforms in the next video.